This video is going to be an introduction to, surprise, gases. Gases are important to us. We often think about explosions, sometimes in a good sense, sometimes in a bad sense. And many explosions are the result of gases from a chemical reaction or a physical change building up inside a container, sometimes rapidly, until the container can no longer hold the gas and it breaks apart violently. Explosions, of course, can be very dangerous, but they can also be very good. Explosions occur inside the cylinders in our car all the time. Gases are also important raw materials in manufacturing. Things like hydrogen and nitrogen, oxygen, fluorine, chlorine are all used extensively to make products that we feel like we have to have in our daily lives, things that are very useful to us, sometimes things that are life-saving. Of course, we know about gases and how important they are to living things. Oxygen and carbon dioxide, that is, and nitrogen are all important to animals and plants respectively. And perhaps the most common way in which we interact and think about gases is the thing that we do in the morning before we go outside, when we say to ourselves or we ask someone, well, what's the temperature outside? And what we really mean when we say that is, what's the temperature of the air? So there's a case where the properties of gases are very important to us. And as we study gases, we're going to think about several different properties. Gases, like many things, have lots and lots of properties. But we're going to think about 4 properties in particular of samples of gas. And these 4 properties are going to help us understand what happens to gases when things change and how they behave. Before we do that, let's think about our triangle here. This is a way of thinking about what we do when we study chemistry. We try to connect the things that we can observe in the real world, things that we can measure in the real world, the so-called macroscopic things, with what's happening to very tiny submicroscopic particles like atoms and ions and molecules. And then sometimes we make a connection to how scientists write that down. What sort of symbols and equations and formulas do they use? Well, in this particular lesson, this particular video, we're going to try to make a connection between the macroscopic world, and that is things we can measure with respect to gases, and what's happening to the individual particles that make up a gas. So we're going to start off by thinking about 4 different properties of gases, and these are the things we'll be most concerned with as we study gases and gas laws. So one of those important properties is the one we just mentioned when we think about what the weather is outside, and that is temperature. And temperature is really a measure of kinetic energy, and that word kinetic means movement. So it's a measure of how fast the gas particles are moving. That's what temperature is measuring. It's measuring the average speed of the particles of the gas in whatever gas we're measuring. Another property that we're going to be concerned with is pressure. And pressure is really measuring how many times the individual gas particles collide with the walls of the container that they're in. So the individual particles are moving around, we'll say more about that later on, and they bang into the walls of whatever container they're in. So, for example, this room that I'm in right now is filled with gas, it's filled with air, and the gas particles are banging into the walls in the room, those are the edges of the container, and they're creating some pressure by doing that. Another thing we're going to be concerned about as we study gases is the volume of a gas. And volume is a measure of how much space the gas takes up. And so what we're really thinking about when we're thinking about that is the size of the container that the gas is in. That's the volume of the gas. And the final thing we're going to be concerned with when we talk about gases is the number of gas particles. Now remember, we've thought about the fact that atoms and molecules and ions are extremely small, so small that we can't count them one by one. But we can keep track of large numbers of those particles. So when we talk about the number of gas particles, what we're really going to be meaning is the number of moles of gas particles. So those are the four properties we're going to think about: temperature, pressure, volume, and the number of moles of particles. And we'll see how those things are related to each other as we go on in our study of gases. Now, we can explain these properties and why they change and how they're connected to each other by thinking about what the individual particles of gas are doing. And when we do this, we're thinking about the kinetic theory of matter. There's that word kinetic again. So the kinetic theory of matter is thinking about how the particles in matter move around, where they are, and how they're moving around. And the kinetic theory of matter, as it applies to gases, is a simple model about the particles and their movements, and it explains the behavior of an ideal gas. Now, a perfect, very simplified gas. And you say, well, okay, well, what use is that? Aren't we really concerned with what really goes on in the real world? And it turns out that this kinetic theory, which we're going to talk about in a minute, does a very good job of explaining what happens to real gases when they're at some sort of normal temperature and pressure. Extremely high pressures, hugely high pressures, very, very high or very, very low temperatures. The kinetic theory of matter doesn't work too well. But for the sort of gases that we deal with every day, the outside air, the gas in inside a balloon, the gas in an experiment, inside a container, the gas in a manufacturing plant, this kinetic theory of matter really can tell us what's going on. So let's see what the parts of the kinetic theory of matter are. Let's do it by going to this page here. So the kinetic theory of matter contains 5 assumptions. We can just think of them as 5 parts of the kinetic theory of matter. The first one is that gas particles are very small. How small are they? They're so small that we don't have to pay attention to the amount of volume an individual particle takes up. The gas particle, we can sort of ignore the fact that gas particles have any size at all. So here's the second part, the second assumption of our kinetic theory of matter, and that is that gas particles are far apart. Now what this means is not that we have to take a $15 cab ride to get from one gas particle to another. What it means is that the distance between particles is much greater than the size of the particles themselves. So for example, if we have 2 particles of gas, and let's say they're this big, according to our kinetic theory of matter, they are not, on average, this close together because the distance between these 2 small dots I've made here is about the size of the dots themselves. What we really mean is that if we had one gas particle that was this size, another gas particle would be some distance away from it, so that the distance between them is much greater than the size of the gas particles. Of course, the particles we're drawing up here are not the real sizes of gas particles. Gas particles are much smaller than that. But the idea is that the distance between them is bigger than the diameters or the dimensions of the particles themselves. Here's our assumption number 3 for our kinetic theory of matter as it applies to gases. And that is that gas particles are in constant random motion. There probably ought to be a comma right here. They're in constant motion, which means they're moving all the time. So gas particles are never sitting still. They're moving around all the time. And they're not all moving in the same direction. That's what we mean when we say random. So if one particle is going that way, another might be going that way, another might be going that way, another might be coming out of the board towards the camera, another might be going in the direction of the board or at any kind of an angle. So the gas particles are always moving, but they're not all going in the same direction. Here's our 4th assumption for the kinetic theory of matter as it applies to gases. And that is that the gas particles that are moving, remember they're moving all the time, are moving in straight lines. But they stop moving in straight lines when they collide with something. You can think of this as what happens when we play the game of pool balls, right? So you hit the cue ball and it goes along in a straight line until it hits another ball, and then it might veer off, or it might hit a cushion and it might bounce off. So we might have a ball coming into a cushion at this angle, and then it bounces off at that angle. So it moves in a straight line until it hits something. And that's the way we can think of these gas particles behaving also. Part number 5 of the kinetic theory of matter for gases. When gas particles collide with something, they change directions, but they do not slow down. So you might say to yourself, well, that's not very realistic. I mean, if we use the analogy of the pool balls might change direction when they bang into something, but eventually they slow down. They lose their energy and they stop eventually. And that's true. So this isn't perfectly realistic, but remember, this is a model, and if we think about gas particles acting in this way, we can explain a lot about the properties of gases that we observe. So we make this assumption, even though it may not be a perfect assumption, but we make this assumption and it helps us understand what's going on. So let's sum up our kinetic theory of matter, KTM for gases. The gas particles are small, the gas particles are far apart, the particles are in constant random motion, got the comma in there this time. Gas particles move in straight lines until they collide. They might collide with the container, they might collide with each other, and when they do collide, they change direction, but they do not slow down. So thinking of these 5 things and what the particles do helps us explain the properties that we observe in a gas. That's it. 4 things, 4 properties of gases that we're going to be concerned with, and the kinetic theory of matter as it applies to gases. We'll hear more about these things as we go along in our gases unit. Over and out.